Hello, my loves. Here we are at Wednesday, April 8th for our math and science lessons. So you're here right now watching my video. If you did not already watch the Math Antics video, please stop this video and go to this one. I want you to watch this video first. Get yourself an idea of what we're dealing with, and then you can come back to my video here. Today's lesson is all about quadrilaterals. Our standard for today, I can understand that attributes belonging to a category of two-dimensional figures also belong to all subcategories of that category. So we were talking before how rectangles are a category and a subcategory are squares, because squares are a special type of rectangle. And we're going to continue with that because rectangles and squares are all a subcategory of quadrilaterals. Quadrilateral means four sides. So remember that a plane shape is a two-dimensional figure. And a closed shape means that all sides meet with no gaps. A polygon has three or more line segments connected at vertices. So a polygon is a special kind of closed shape. It's special because not only is it closed, but it's made of line segments that are connected at vertices. And then a quadrilateral is a special type of polygon, which is a special type of closed shape, which is a special type of plane shape. Oh my goodness. And it's special because it has four line segments. And those line segments are connected at four vertices, and it has four angles. Here's our goal for today. Our objective is to show that you can identify the properties of quadrilaterals and then classify them, name them by their sides, angles, and parallel lines. Here's our essential question. What properties help you classify quadrilaterals? Well, we know it's a quadrilateral because the property is that it has four sides. But we're going to further name those quadrilaterals like square and kite and rectangle and rhombus. So you need to think what properties help you classify those special shapes. Here are the lead measures for today, our steps. That Math Antics video that you should have already watched. And we're going to do an animated math model today and unlock the problem. And I'm going to show you some fun examples on Math is Fun. And don't forget those math grades that are due every week. Every Monday, you're getting 2 brand new lessons that I assign. And then once you're done with those, finish up your independent lessons on iReady. Now, we've got a new rule here. The new rule is you have to do 50 minutes every week for math, and you have to do 50 minutes every week for reading. And it's not just so you can get these great grades. It's because we're taking attendance using iReady. So if you are on iReady for 50 minutes in math and in 50 minutes in reading, then you have perfect attendance for the whole week. But if you only have 40 minutes, then that means you are absent for one day, okay? Make sure that you get your 50 minutes in. You need to get all those 50 minutes in for math and 50 minutes in for reading. All right, let's talk about those plane shapes again. Those are two-dimensional flat shapes, and a closed shape is a plane shape that's closed on all sides. For example, this Venn diagram, this is a very interesting Venn diagram. This circle is a plane shape, and that giant circle is also a closed shape. But that circle is not a polygon, because in order to be a polygon, it has to be a closed shape that has more than 2 sides and is made up of line segments. So a circle just has one side. Basically has the outside, and it's curved. It's not made of line segments. So a circle cannot be a polygon. A quadrilateral is a special kind of polygon, and it has 4 sides. Quadrilateral literally means 4 sides. Now everything right here is a quadrilateral, of course, except for those circles. This is a quadrilateral out here, and so is this one. But it's not inside the circle, and let's see why. Because we have a subcategory called, whoop, get back there we go. We have a subcategory called parallelograms. That means inside this circle, everything is a parallelogram. So here are two examples of parallelograms. And rhombuses, rectangles, and squares, they're all parallelograms. And of course, they're all quadrilaterals. Now, parallelogram means it has a pair of parallel sides. It has two pairs, I'm sorry. Parallelogram means two pairs of parallel sides. And how I remember what parallel means is I hear pair of L's. If you look at a pair of L's, they are actually parallel. And it means the sides will never, ever meet. That was reach and meet at the same time. They're never going to meet. So if this line segment continued forever and this line segment continued forever, they're going to stay the same distance apart. They're not going to meet. And if this line and this line continued forever and ever, they're not going to meet. That's what makes them parallel. Now these are parallel, but so are all of these. A rectangle is a special kind of parallelogram because this is a parallelogram that has 4 right angles. Remember, rectangle means right angle. 4 right angles. And then we have a rhombus. A rhombus is a special type of parallelogram because it has 4 equivalent sides. Every side is exactly the same. And then we have a square. A square is a rectangle, and a square is a rhombus. It has 4 right angles, and it has 4 equivalent sides. A square is a rectangle, a square is a rhombus, a square is also a parallelogram and a quadrilateral, and it's a polygon, and it's a closed shape, and it's a plane shape. Whew, that square has a lot going on. Okay, please again remember those 2 iReady lessons that I assigned. They're due by Sunday. On Monday, I will pull those grades. Here we are at our animated math model for classifying quadrilaterals.
Quadrilaterals are figures with 4 sides. They can be classified based on congruent and parallel sides. Click each figure to see its definition.
Okay, so how are we classifying quadrilaterals? We're classifying them by 2 things, by their parallel sides and by congruent sides. So look at this general quadrilateral. Sometimes it's called irregular because it doesn't have the same length of sides and it doesn't have the same angle. But here we have a trapezoid. Oh, sorry. And it doesn't have any parallel sides either. And then we have a trapezoid here. Let's see what the properties of a trapezoid are.
A quadrilateral with at least 1 pair of parallel sides is a trapezoid.
Okay. Do you see where it says at least 1 pair of parallel sides? Sometimes you'll see a definition of a trapezoid that says exactly 1 pair of parallel sides. And what's really confusing is here in this example, this at least is going to change to exactly in just a few minutes. But I want you to remember that while we're working, a trapezoid, our definition of a trapezoid is at least 1 pair. So that means if it has 2 pairs, it's still a trapezoid. At least 1 pair. Keep your eye on this because it's going to change. And I'm not exactly sure the exact moment. I haven't caught it yet. Maybe you can catch it for me.
A quadrilateral whose opposite sides are parallel and congruent.
Okay, parallelogram. Remember, that has 2, it's parallel, pair of L's. I have a pair of L's here, and then another pair of L's there. There are 2 sets of parallel sides. This only has 1 pair. So a parallelogram is a special type of trapezoid because it's got 2 pairs of parallel sides. And this side is congruent here. Remember those markings? And these are different markings that tells me this is only equal to this, and it's different than these other two. What about the rectangle?
A quadrilateral with opposite sides congruent and 4 right angles is a rectangle.
All right, the opposite sides are congruent. That means this top and this bottom are congruent. They're opposite. And this left side and that right side are congruent, right? They're opposite. And it also has 4 right angles. A rectangle is a parallelogram.
A parallelogram with 4 congruent sides.
Okay, a rhombus has 4 congruent sides. Now, a rectangle is not necessarily going to be a rhombus because you have to have right angles to be a rectangle. And this rhombus here does not have right angles. But you know what rhombus does have right angles? This one right here. That's a special rhombus called a square.
A quadrilateral with 4 congruent sides and 4 right angles is a square.
Okay. We're still there. We've still got at least one pair of parallel sides, right? What? There it is.
Picture to see how the faces of the box show 2 types of quadrilaterals.
Look what that's where it is. It took us both looking. Exactly one pair? No, it's at least one pair.
So, the face of the top section of the box shows a square. And the face of the lower section shows a rectangle.
Besides square and rectangle, what other names can you use to classify the faces of the box? Click this button for an answer.
All right, let's start with the square. The square, obviously it's a square, but it's also a rhombus, and it's also a rectangle, and it's also a parallelogram, and it's also a trapezoid if we use the definition of at least one pair of parallel sides. Then, of course, it's a quadrilateral.
A square can also be named as a rectangle, a rhombus, a parallelogram, and as a quadrilateral. A rectangle can also be named as a parallelogram and as a quadrilateral.
Now, they didn't name these two as a trapezoid. Let's see what happens on the next page.
Classify the figure in as many ways as possible. Check all the answers that apply.
Okay, so we have here a quadrilateral. It's got 4 sides. Are the sides parallel? Yes, they are. Is it a square? I don't see right angles. It can't be a square. And because there's no right angles, it's definitely not a rectangle. Is it a rhombus? Yes. Now here's the question. Is it a trapezoid? Well, the screen right before us said exactly, but then the screen before that one said at least. Well, let's see what happens.
That's right.
Okay, they're counting this as a trapezoid. Oh, they just like to confuse us.
Classify the figure in as many ways as possible. Check all the answers that apply.
All right, check all that apply. Oh, solve everything. Yes, we're gonna, let me check. 1, 2, 3, 4. Yep, it's quadrilateral. Parallelogram, there's a pair, but that's not parallel. They'll eventually meet, not you. Square, right angles, nope. Rectangle, definitely not. Rhombus, every side is equal. That one's definitely smaller. Trapezoid, yeah. A trapezoid has at least one pair, and there is at least one pair.
That's right.
All right, last one.
Classify the figure in as many ways as possible. Check all the answers that apply.
Okay, well, we know it's a square and it's a quadrilateral. It has 2 pairs of parallel sides. It is a rhombus because every side is equal. It's a rectangle because every angle is a right angle. It's a square. Let's see if we get this one right.
That's right.
Woohoo! All right, awesome. All right, here we are at Unlock the Problem with Quadrilaterals. All right, how can you classify and compare quadrilaterals?
Let's see how you can classify different types of quadrilaterals. Let's unlock this problem. A seating chart for a baseball field has many four-sided figures, or quadrilaterals. What types of quadrilaterals can you find in the seating chart? There are special types of quadrilaterals. You can classify quadrilaterals by their properties, such as parallel sides and perpendicular sides. Parallel lines are lines that are always the same distance apart. Perpendicular lines are lines that intersect to form four right angles. A quadrilateral has four sides and four angles. Let's complete the sentences that describe the different types of quadrilaterals.
All right, a trapezoid is a quadrilateral with at least one pair of blank sides, one pair of pair of L's.
A trapezoid has at least one pair of parallel sides. Let's look at a parallelogram.
A parallelogram is a special trapezoid with opposite blank that are blank and parallel. They have opposite sides, right? Remember those opposite sides? They're congruent and parallel. So those little marks mean that they are the same length. They're congruent, and they're never going to meet their parallel.
A parallelogram is a special trapezoid with opposite sides that are congruent and parallel.
Now let's look at a rectangle.
All right, a rectangle is a special parallelogram with blank right angles. How many right angles? And four pairs of what kind of sides? Remember, we are comparing them. We're categorizing them by using their parallel sides and by using their angles, right? So four pairs of perpendicular sides.
A rectangle is a type of parallelogram. It has four right angles and four pairs of perpendicular sides. Another type of parallelogram is a rhombus.
So really quick, because I can't get back to that rectangle, I want to talk about that rectangle right here. Rectangle is a very special one because a rectangle has two pairs of parallel sides, parallel right here and here, and the top and bottom are parallel. And it's perpendicular because it makes a right angle. So remember, parallel doesn't make a right angle, but perpendicular does make a right angle. So a rectangle and a square are pretty cool because they've got two sets of parallel sides and they also have perpendicular angles. We've got a rhombus here, and it's a special parallelogram with blank congruent sides. What kind of congruent sides? Or, oh, it's a small spot. I'm thinking that's going to be a number, right? I think it's going to be 4.
A rhombus has four congruent sides. Next, let's take a look at a square.
All right. Now, we were just talking about that, right? If it makes a right angle, that means these two sides are perpendicular. So the left side is perpendicular to the top, but the left side is parallel to the right side. Remember, I tell you, be very careful about what they're asking you because there are lots of different answers for the same shape and lots of different questions that you have to find the answers for. So the left side is perpendicular to the top. or the left side is perpendicular to the bottom. What about the top and the bottom? Are they perpendicular? No, right? They're parallel. Very good. So a square is a special parallelogram with blank congruent sides and blank right angles. You know this answer, don't you?
A square is also a parallelogram. It has 4 congruent sides and 4 right angles. Now let's look at the types of quadrilaterals found in the seating chart. There are trapezoids, parallelograms, rectangles, rhombuses, and squares. You can use a Venn diagram to sort quadrilaterals and find out how they are related. Let's sort the quadrilaterals. First, let's separate the trapezoids and the parallelograms.
Okay, so we looked at this already before, and we found these two quadrilaterals don't fit inside this Venn diagram because inside this Venn diagram, you have to be a trapezoid. And these are not trapezoids because a trapezoid has at least one pair of parallel sides, and these don't have any parallel sides. So trapezoids, there are two that are just trapezoids. But I have two figures that are not only trapezoids, but they're also parallelograms because they have two pairs of parallel sides. And then I've got two figures here that are not only rectangles, they're also parallelograms and trapezoids. And over here, these guys are trapezoids, parallelograms, and rhombuses because all 4 sides are equal. And then we have this very selective group, squares. In order to be a square, you have to be a rhombus and a rectangle, which means you're also a parallelogram and a trapezoid and a quadrilateral. And what else? A closed shape and a plane shape and a polygon. Oh my goodness, a square is many, many, many things. All right.
There's often more than one way to classify a shape. Classify the quadrilateral in as many ways as possible. This quadrilateral has 4 congruent sides. Select all of the possible classifications for this shape. When you're ready, check your work.
Okay, so to classify means to put it in a class, like to put it in a category. You are in a class. You are in my class. You're in Miss Allison's class. So that is one category. It's a subcategory because yes, you're in my class, but you're also in 5th grade. And you're not only in 5th grade, you're also at AGA. So all of these are subcategories, and that's what it means to classify something, to put it in a group, to name it, to make it a little bit special. So we know that this is a quadrilateral. Not only did they tell us, but we know that it has 4 sides. But let's see, is it a parallelogram? Does it have 2 pairs of parallel sides? Yes. How about a rectangle? What do you think? Rectangle. Whoop. You're right, it doesn't have 4 right angles. How about rhombus? Rhombus has 4 equivalent or congruent sides. Yes. Trapezoid. I wonder. Because we've seen one definition that says exactly. We saw another definition that says at least. Let's go for it. And square. Nope, not a square. Oh, we got it right.
Good job. The shape can be classified as a quadrilateral, a trapezoid, a parallelogram, and a rhombus.
Here we are at mathisfun.com. And I love this website because all you have to do is type in what you want to search, And you'll get so many really cool things popping up. We have interactive quadrilaterals. There are some really cool things that you can draw your own quadrilaterals. You can play around with them. Here, quadrilateral just means four sides. Quad means four, lateral means side. A quadrilateral, as we know, has four sides, and it's a two-dimensional or flat shape. It's closed and it has straight sides. But look, we haven't seen something like this yet. This is a quadrilateral. Is it? Let's see. 1, 2, 3, 4, 5. I don't know. What do we think? Does that look like a quadrilateral? Unless, oh, is that one side? That is one side, maybe? 1, 2, 3, 4. I don't know. I'd have to think about that. This one, let's see. 1, 2, 3, 4. That's a quadrilateral. I don't think that's a quadrilateral. What do you think? This is cool because look, you can manipulate these points and make different quadrilaterals. All right, let's talk about the properties of quadrilateral. We know it has four sides, it has four vertices, but here's something that's super duper important to know. The interior angles add up to 360 degrees. It's like a circle, 360 degrees. Well, that's kind of cool. So all of these angles, look, we've got 80, 68, 118, 94. They added them all up, and they all equal 360 degrees. And look at this. This is a square, or a rectangle also all has 90-degree angles. 90 times 4. Well, I know 9 times 4 is 36. So 9 tens times 4 will be 36 tens. So yeah, they all add up to 360 degrees. Here are some types of quadrilaterals: rectangles, rhombuses. Now, so we're used to these, but here's a kite. A kite's an interesting one. Adjacent pairs of sides that are equal. So this blue line is congruent to this one. That's what adjacent means. It's kind of like catty corner next to each other. And then these red sides are adjacent to each other, and they are equivalent. They are congruent. And we have two congruent angles right here. And then you see how we have that little perpendicular line there showing a right angle in the center. So we're talking about all these shapes already. And I want to scroll down because we've seen a Venn diagram showing you how these figures are related, but I wanted to show you the family tree chart. And this is cool because look at this. It kind of looks like the food web that we've been studying in science. So the quadrilateral is at the top, and it's kind of going down and down and down. This would be kind of like that, the producer, right? Except in the food web, the producer's at the bottom. But this is a quadrilateral because everything is affected by that, or everything is a quadrilateral. A quadrilateral, right here, a kite is a quadrilateral. A trapezoid is a quadrilateral. An isosceles trapezoid, a rectangle, everything underneath is a quadrilateral. Now look here, a rectangle is an isosceles triangle. And a square is a rectangle. A square is also an isosceles triangle. A square is also a rhombus. A square is also a parallelogram. A square, oh my goodness, it's all of these. A square is everything. Here's the answer to that question. Complex quadrilaterals, oh yes. When two sides cross over, we call it a complex or self-intersecting quadrilateral like these. They still have two sides, but two sides cross over. So think about it if you had a piece of paper and you twisted that paper. It's still a quadrilateral, but it's just twisted. Well, that's the answer to our question. Yes, it's a special type of quadrilateral. Okay, let's answer some questions here. All right, let me grab my pen and let's see what we have. What is the name of this quadrilateral? Well, let me see. I've got 2, 2, 2, 2. I don't know if those are inches or what, so I'm going to call them units. 2 units is the length for each side. So a square has all 4 of the same sides, but a square has right angles. This doesn't have right angles. Is it a kite? Well, it says a kite has adjacent that are the same. Hey, those are the same. And these are also the same. So it could be a kite. Square, nope. Rhombus, or trapezoid. Now we know that excuse me, we know that a square is a special type of rhombus and it's a special type of trapezoid. But I have a feeling they want me to just name one thing and not say that it's everything, because they didn't say select all that apply. I'm going to go with rhombus. Correct. Yes, because it's got all equal sides. All right, look at this. We have an isosceles trapezoid. And they want to know what is the size of angle A. So I need to find what is angle A. Now, how am I supposed to find that? Okay, I remember that all of these angles, A, B, C, and D, are going to equal 360 degrees. Can I undo that? Perfect. They all equal 360 degrees. So I've got 59, which is D, and 59, which is C, plus A plus B equals 360. So I know that if I add them all up, I'm going to get 360. But how do I know what's going on here? Okay, well, here's the thing. Because they didn't tell me this angle, I have to assume that they are congruent. They're not going to make me guess. So I'm going to assume that that's congruent. So my first step is to find out what these two are. Well, I know that 50 plus 50 is 100. And I know 9 plus 9 is 18. So I've got 118 plus A plus B equals 360. So I know that these two right here are 118. So that means that these two have to be what? Oh, I forgot my 0 again. 360 minus 118. All right, can't do it. I can't subtract the 0 or the 8 from the 0, so I need to regroup. And this becomes a 10. And that's a 10. And that would be a 2. 5 minus 1 is 4. 242. So that means these are together 242 degrees. All right, so 242 degrees. A, B, C. It's none of them. Oh, that's why, because 240 degrees is both of those. So how do I find just one of those? I'm going to divide by 2. 2 goes into 2 one time, 2 goes into 4 twice, and 2 goes into 2 one time. So it is D, 121 degrees. Let me get my mouse. Come on, mouse. There we go. 121 degrees, and we got it right. All right, let's take a look at this one. All right, so quadrilateral ABCD. Well, ABCD is a quadrilateral. What's the size of angle D? Well, we know that all of these plus this is going to equal 360 degrees. So let's find out what all of these are. I've got 115, 107, and 83. I have 7, 8, 9, 10, plus 5 is 15. 8, 9, 10. 1, 2, 3. I have 305. So when I subtract, I have 55 degrees. 55 degrees is what my answer is. And yes, I'm right. And how I could always check my thinking is I could plug in that 55 degrees, and then I can add them all up with 115, 107, 83, plus that extra 55, and they should all equal 360. So let's see, 7 plus 3 is 10, 5 and 5 is another 10. That would be 20. And I've got 8, 9, 10, 11, 16. 1, 2, 3, it is 360 degrees. Yes, awesome. All right, my loves, we are done. On my webpage for today's lesson, you have some examples of IXL activities that if you wanted to do some extra practice, these are all ones that match with today's lesson. You can identify parallelograms, trapezoids, all that kind of fun stuff. Get as much practice as you possibly can, because everything that you do is just going to make your brain bigger, better, and stronger. All right, I'll see you tomorrow.